Okay, next question. A marble rolls across a flat surface. Its initial speed is 1 meter per second, but it comes to rest after 10 seconds. Find the acceleration of the marble and the distance traveled by the marble as it comes to rest. Okay, so we have a couple of things in this problem. First off, it says speed, not velocity. Speed does not have direction to it, so we're not going to say anything about it being positive or negative. Okay? The same is true for distance. Like distance and height, those do not have direction. Only displacement does. Alright, so the marble's not going to travel a negative distance. Let's list the things that we know about the marble. We know the initial speed is 1 meter per second. We know that it comes to a rest. Okay? If it comes to rest, then that means that its final speed is 0. And we know the time interval is 10 seconds. Okay, now let's list what we want to know. We want to know the acceleration, and we want to know what the distance is. Alright, so let's do one at a time. How about we figure out what the acceleration is? So we need to pick an equation that has only those 4 variables and nothing else. So that looks like it's going to be final velocity equals initial velocity plus acceleration times time. And we want to figure out what the acceleration is. So we're going to subtract the initial velocity from both sides. We're going to get final velocity minus initial velocity equals acceleration times time. And this time we're going to divide it by time so that we can have acceleration on its own. So acceleration is equal to the final velocity minus the initial velocity divided by time. You could put a little x over here next to this acceleration to let me know that it's in the x-axis. But if you're not doing a problem that has both x and y motion or just y motion, x is usually understood. Alright, so let's plug that in. Okay, the final velocity is 0 because it came to a rest. The initial velocity was 1, and I've accidentally switched over and started saying velocity instead of speed. And then time is 10 seconds. Alright, let's check our units. We've got meters per second on top and seconds over 1 on bottom. Let's double check up here and see what would happen to that, because that's our complex fraction. We solve that by multiplying by the reciprocal of the denominator, both top and bottom. So this reduces to 1 on the bottom, and then we've got meters times 1, which equals meters, and you've got seconds times seconds, which equals seconds squared. So meters per second squared, and that's the correct unit for acceleration, so we've done our algebra correctly. You're going to get negative 1 on top, and you've got 10 on bottom. So you get negative 0.1 meters per second squared as our acceleration. And that negative sign is important because it shows us that the object was slowing down. A negative acceleration is decelerating, alright? And it makes sense, since the object was coming to a rest, that it was decelerating or slowing down. Okay? So now let's figure out how far it traveled, alright? So we've got initial velocity, final velocity, time, and we want to know displacement. Alright? We also just figured out what the acceleration is. Okay? So we have a couple of options available to us. Let's write down the equations that we can use here to figure out displacement. There are 2 UAM equations that have displacement in it. Alright? We've got delta x equals initial velocity times time plus 1/2 at squared, or we've got final velocity squared equals initial velocity squared plus 2a times the displacement. Okay, well, we just found out what the acceleration is, so we could plug that one in here and use the top equation. and we figured out what the acceleration is so we can use it here as well. There were no equations we could have used previously without having that acceleration first. So it's really up to you about which equation you want to use. Alright? Since this one is already set up to solve for delta x and I don't have to rearrange anything, I think I'm going to go with the first one. So we're going to say delta x is equal to the initial velocity was 1 meter per second times the time, which was 10 seconds, plus 1/2 times the acceleration, which we said was negative 0.1 meters per second squared, times the time squared. Alright, so here we need to pay attention and follow our order of operations. Okay? We need to do our exponent first. Alright, so you need to do your 10 times 10. So we're going to get 100 because we squared the number, and then we have to square the seconds. You square everything inside the parentheses, so we get 100 seconds squared. Alright, now we need to take 1/2 of our negative 0.1. So we get negative 0.05 meters per second squared. Those will be multiplied, and I'm just going to kind of bring these down because we haven't done anything with them yet. I guess we could since the numbers are simple enough. 1 times 10 is 10, and then here we've got a seconds in the numerator and we've got a seconds in the denominator, so those are going to cancel each other out. So we're left with meters. So 10 meters plus this stuff. Now we've got a second squared in the numerator and a second squared in the denominator, so those cancel out and we're left with meters. So meters plus meters is going to give us meters, which is the correct unit for displacement. So we're good to go on our units. So let's just bring this down. 10 meters plus, now we have to do our negative 0.5 times 100. So we're going to get negative 5 meters. So this is the same thing as saying 10 meters minus 5 meters. So that's going to leave us with 5 meters. Now let's double check our sig figs. Okay. Here we have 1 sig fig and here's 1 sig fig. So our answer can only have 1 sig fig. And this one does only have 1 sig fig, so we're good to go on that one. So we figured out that the marble traveled 5 meters and that it had an acceleration of negative 0.1 meters per second squared. Alright, we'll leave it there for this one. Thank you for learning with me. I'll see you next time.